Okay, so welcome back to the grade 11 math review. Last time I did some factoring, and now what I'm going to do is I'm going to continue on with this worksheet. And if all goes well, I'm just going to keep checking my recording. If all goes well, I'm just going to finish through this first page. And so that'll be basically the first page of the exam review. The website that I got this exam review from is the tvdsb.ca website. So I'll provide a link. I don't think I provided a link in my previous video where I did simple factoring, but I will. And so you can check it out in the description. It's a PDF file. And once this entire review is done, I'm going to provide the PDF with the solutions. So the whole point is to provide like a little walkthrough. Okay, so simplify each of the following and state the appropriate restrictions. So we're going to do 2a, right? So we've got x squared plus 4x minus 12 divided by x minus 4, or x squared minus 4. Okay. Now, first things first, what you want to do is you want to state restrictions. The best way to do this is to whenever you've got a quotient, right, the best way to get a restriction out of that is to make sure that the bottom doesn't equal 0. Whatever x values do make the bottom equal 0, that's a restriction on the variable x. So in this case, we have x squared minus 4 equals 0. Okay, so you set it equal to 0 and try to solve for x. And what you end up getting is you get x equals plus or minus 2. So what you say is x cannot be plus or minus 2. So it can't be 2, it can't be negative 2. And now you can do a factoring, and then you'll see one of the factors cancel out to simplify it. So x squared plus 4x minus 12. Well, two numbers that multiply to 12 and have a difference of 4. So two numbers that I can think of are 6 and 2, more specifically positive 6 and negative 2. And the reason why I say positive 6 is that the bigger number has to take the positive if the middle term here is positive, right? So you go x plus 6 and x minus 2. And here in the bottom, this is a difference of squares, right? So we've talked about that before. You could check out my previous video on simple factoring where I introduced that. And that's basically x plus 2 then. A plus b times a minus b, so x minus 2. And now there you go. So you get a factor that can cancel and simplify the expression. So you get a cancellation. And the end result is x plus 6 over x plus 2, and you are done. Okay, so that's the first one. I don't know if it'll really be helpful to do like all of them. I think I'm going to do maybe C and E. Okay, if you do you want the other questions done, just give me a comment, and I'll work on them. So I think, by the way, yeah, D has a division sign. You know what, let's do division. So I'll do D instead, just because D has an extra step versus the multiplication problem in part C. So let's work on that. So we've got x squared plus 7x plus 12 over x squared minus 9 divided by, okay, x plus 4 over x minus 4. Now, gets a little confusing. The division means, that this whole term, so division means that this whole term is under this whole term. Okay, so there are three potential restrictions that we can think of, right? So one is this can't be 0, this can't be 0, and this can't be 0. Okay, so what that means is this is a difference of squares, so x cannot be equal to plus or minus 3. That's one. That's two solutions, excuse me, on restrictions. And this comes out, and it's very easy. So that means that x can't be negative 4 and it can't be plus 4, right? Because if x is 4, then x minus 4 is 0, and if x is negative 4, then x plus 4 is 0. So those can't be allowed either. Now once we have that, we could start simplifying. But before you do that, when you divide by a fraction, you have to multiply by the reciprocal. What the reciprocal means is you flip, right? So here's what you do. X squared plus 7x. This expression over here is equal to x squared plus 7x plus 12, okay, divided by x squared minus 9 times, okay, I'll just leave a dot because the time multiplication symbol gets kind of confusing since you're also using x. I'll use a dot, so you get x plus 4, oh, excuse me, so I flip it, right? So the reciprocal, x minus 4 divided by x plus 4. And that's it, that's the flip. So now I can simplify and cancel like terms, and I'm done. Okay, so x squared plus 7x, let me just check that the recording is still good. Yeah. Okay, so x squared plus 7x plus 12. Well, that's x plus 3, right? And x plus 4. Check that out, right? So you get 3 times 4 is 12. They add together, you get 7. We're good. Okay. And then you've got a difference of squares in the bottom. Again, check the previous video. That's x minus 3, x plus 3. Okay, great. And then you've got x minus 4, x plus 4. What's great is I've got multiple cancellations that I can do here. So x plus 4 cancels with x plus 4, and x plus 3 cancels with x plus 3, and it simplifies to a beautiful x minus 4 divided by x minus 3, okay, as the ratio. X minus 4 divided by x minus 3. Okay, now I'm going to go to a new page. Okay, and what did I just do? I just did D, so I'm going to do E, right? So x plus 6 over x squared plus 2x minus 3 plus x minus 5 divided by x squared minus 1. So let's write that out. So I've got x plus 6 divided by x squared plus 2x minus 3 plus x minus 5 divided by x squared minus 1. Okay, so in this situation you don't need to flip anything because you're not dividing, right? You're not doing x plus 6 over x squared plus 2x minus 3 divided by this term, right, this quotient. You're just adding. So but I still have to, state restrictions. That doesn't change. So restriction here and restriction here. Okay, so so this sucker can't be 0, all right, and that means that x can't be plus or minus 1. Okay, here we've got a bit more of an issue because now we have to do factoring. It doesn't stick out like a difference of squares. So if you do the factoring, that turns out to be, and if you factor, what's interesting is that, or beneficial about this is that you're basically you're killing 2 birds with a single stone. So that turns out to be x plus 3 and x minus 1, because 3 minus 1 is 2, positive 2, we're good. And so then x can't be 1, but we already know that, right? So I don't have to restate it, but x can't be negative 3. So these two, not inequality signs, these two statements are your restrictions. Now, if I factor x plus 6 over x plus 3, x minus 1, why don't I give more room here? Why don't I go down? Let me do this. So x plus 6 over x plus 3, x minus 1. Remember, the reason why I've got these two factors is because of that factoring. And then x minus 5 over x squared minus 1. Now, x squared minus 1, right, is x plus 1 times x minus 1, okay? X minus 1 is in both denominators, so it has a common factor in the denominator. The lowest common denominator would then be a multiple. It would be x minus 1, where you just bring all the factors together. X minus 1, x plus 1, x plus 3. That's the lowest common multiple as well. So lowest common denominator is the lowest common multiple in that case. And here I have to multiply the top by whatever's missing. So on this left side, notice I don't have x plus 1. So I multiply it through, and I go x plus 6 times x plus 1. Okay, and then I add, and then I do x minus 5, okay, times whatever's missing here, and that's x plus 3. Now, in this case, all you have to do is expand and simplify, and you're pretty much done. Okay, and that's that problem. So let's see if I could do that really quick. So x squared, should I do it really quick for you guys? Should I, like, kill it? I don't know. Should I, like, brute force it? Why don't I brute force it? X squared plus 6x plus x plus 6. Now 6x plus x is 7x. Okay, so I just have to add them together, and here I got x squared minus 5x plus 3x, that's negative 2x, okay, minus 15, and divided by x minus 1, x plus 3, x plus 1, x plus 3. Now 7x minus 2x is positive 5x. Okay, so I'm going to kill those off. Positive 5x. Okay, and x squared plus x squared is 2x squared, right? 1 apple plus 1 apple is 2 apples. And 6 plus negative 15, that's 6 minus 15, that is negative 9. So, minus 9. Okay. Now, can I factor the top? Two numbers that multiply to 18 have a difference of 5. Two numbers multiply to 18. 9 and 2, and 6 and 3, 18 and 1. Nope. So I think that's pretty much it. You can't really factor it further, and I would leave it at that. I might make a mistake, but you guys can correct me in the comments section. The general mechanics is the same, though. Is pretty much okay. Okay, so why don't we keep going? Let's keep going to the next page. What does the next question say? Show that the following expressions are equivalent and find any necessary restrictions. Okay, this is ballsy. Let's do this. So I bet I just have to simplify. I bet I just have to simplify the left side, and the right side will just basically pop out. Let's try this. Why? What the heck, right? So 3a. It's weird how it says 3a, but there's no other question after that. That's pretty weird. That's in part 1 algebraic skills. Okay. X to the 4 minus y to the 4 over x plus y squared, okay, times x squared minus y squared over x squared minus y squared squared divided by that, but that is so when you're dividing, and by the way, I'm going to switch multiplication signs to dots. I hope that's okay. So the multiplication signs are dots. So when you're dividing by a quotient, you are multiplying by the reciprocal. So I'm just going to flip that term. So it's going to be x squared plus 2xy plus y squared divided by x squared plus y squared. And first thing that pops out to me is, notice this. There's a factor of 2 of this guy, and there's essentially a factor of 1 of that guy, right? So what I can do is I can just cancel this whole term, leave a 1, right, a numerical value of 1, and cancel out one of the factors on the bottom. That's the first thing I can do. Second thing I can do is notice that this is the expansion for x plus y squared. Okay, so if you run through it, that's the expansion for it. So I can replace this whole thing by x plus y squared. And what that'll leave me is one of those guys, x plus y squared in the top and x plus y squared in the bottom, so I can kill that off. And then I end up getting x to the 4 minus y to the 4, okay, over x squared minus y squared, all right, times x squared plus y squared. Okay, now here's the beauty of this. I've got a plus b in the bottom, a minus b in the bottom. That gives me a squared minus b squared. But a squared in that context is x to the 4. B squared in that context is y to the 4. So really the bottom turns out to be x squared squared, which is x to the 4, minus y to the 4. But that's exactly what I have on top, right? So I end up getting the same factor on the bottom and on the top, so I get 1. So they cancel out and I get 1. Now what this leaves me with is the right, this right expression has to cancel out to 1. So what I'm assuming is going to happen is that all that stuff except for that 1 at the end will cancel itself out. So let's check that out. So let me write this as left side, right? And right side. Okay, so right side, x plus y times 3x minus y minus 3 times x minus y squared minus 4y. Let me just make sure that everything's okay. Yeah, 4y, 2x minus y plus 1. Okay, so if I do the expansion, I get 3x squared minus xy, right? So that's this part. And then plus 3xy minus y squared. And if I do this expansion, I get negative 3 x squared minus 2xy plus y squared. Okay. And here I get minus 4. Oops. Nope. I get, if I factor in the negative 4y, I get negative 8xy plus 4y squared plus 1. Okay. So how does it cancel out? What happens? Well, look, if I expand negative 3 inside, I get negative 3x squared there, right? So this 3x squared cancels with that thing. Then negative 3 times negative 2xy is positive 6xy, right? And let me double check. Ooh, I think I'm missing a term here. Okay, am I missing a term? I think I am. Yes, this should be 3xy. Okay, that's why. Okay, so I got 6xy and minus 8xy, that's negative 2xy, minus xy, that's negative 3xy, plus 3xy gives me nothing, right? Gives me 0. So this guy cancels with that guy, which cancels with this guy, and that cancels with this. Double check that. And then I've got negative y squared minus 3 times y squared. That's so minus y squared minus 3y squared. That's negative 4y squared. Plus 4y squared gives me 0. So that cancels with that, which cancels with that. So there's basically nothing there, okay? And I end up getting 1 back. So that means that left side equals right side. And I've proven that both equal 1, essentially. So that was the end of basically algebraic skills. Okay, so that's a grade 11 exam review for algebraic skills. I think maybe I'll leave functions and transformations for a new video. Be sure to leave a like, comment, subscribe to the videos, and we really appreciate your support. And we'll catch you for more grade 11 math review. This is Functions. Peace.